Hey guys, welcome to the Biomechanics 2 lecture series of videos. To do this particular practical, which is a biomechanical analysis of the standing broad jump, you will need 5 factors. The first thing that you'll need is the slides pertaining to the biomechanical characteristics of jumping. You will need the Prac sheet detailed or entitled the biomechanical analysis of the standing broad jump. You'll need the Biomechanics 2 manual from theory to application for Biomechanics 2. You will need the Excel template wherein you will capture your data, and then you will need the tracker motion analysis software in order to digitize all of the information that you need. So this particular video is subdivided into 2 parts. The first one is the data capturing, the second part is the data analysis. Okay, so for the data capturing, you'll need the tracker software, and then, like I said, you'll need this template, this Excel template, wherein you will capture the digitized data from the video. Alright, so in your tracker software, this is typically what it looks like, and what you will need to do is open it up, click on File and Open File in order to find where the video is that you've saved. In this case, it's the standing broad jump, and I'll just double click on that, and it will load it. And you should see something like this. You would have your subject with the markers, body markers clearly indicated, wherein you have a wrist, elbow, shoulder, hip, knee, ankle, and toe clearly indicated. You also need a measuring stick in the actual frame, which we use to kind of give a scaling factor to this particular video. Once you have this, you need to set up the coordinate system. So the coordinate system is where everything will be measured from. I typically try and set it out as level as possible, slightly behind the individual. It doesn't really matter where you start from, and then you can kind of tilt the axis if your video was slightly skew. Preferably it'll be completely level, and once you're happy with the grid setup, you can just click it again and it'll disappear, and everything will be given relative to that. So you'll notice here at the bottom it's going to give me X and Y coordinates for wherever this mouse pointer tends to be. So when I hover over a specific marker, it will give me the coordinates of that specific marker. Okay, I still have to set up the scaling factor. So to do that, I insert a new measuring device. So let me just get rid of that. So what I would do is put a new calibration stick in. Right. Normally you only get one. So what we'll do is, let me just get rid of that. Let me just delete this one here. So I'd put a calibration stick in, such as this one over here. You see these 2 crosshairs you would set up on either end of the stick, like so. You can press Control and scroll the mouse button up to zoom in a little bit more closely. So you want to make sure that it's definitely as accurate as possible. Okay, this calibration stick, this orange one, is 92 centimeters. So everything here is given in meters, so I could put in 92 centimeters, but I prefer it in meters, so I'll put 0.92 meters and hit enter. Now this whole scene is calibrated relative to this measurement, right? So I can click up here again and I'll get rid of it, and everything is set up the way in which I need it to be. Next thing is to kind of set the video to the start of my analysis. So I have this scroll bar down here, and you'll notice if I hit the play button, it will slowly start playing. So the key here is for you to put the stick between your feet in the frame or in the plane in which you will be moving. My analysis is about to start. Options over here, just play it frame by frame. I need the person to be in the deepest squat position in order to assess their propulsive phase, flight phase, and landing phase. So you can see here this particular athlete is about to start, right, swinging forward. So I need her at the bottom of the squat, As here she's still going down, down, and then she's going to hit the deepest portion. So I would start my analysis from here. Okay. We will assume symmetry at this point in time to make our analysis slightly easier. So in this case, we would assume that her left arm is basically at the same level as her right arm, which is not in this case, which is an indication of not the greatest technique, but in any case, we will assume symmetry for now. Just to give an indication of how to go about this analysis. You can see here I still have my wrist, elbow, shoulder marker, my hip, knee, ankle marker, and the most anterior aspect of the toe in the frame. So what I would do is I would hover over this wrist marker, and you will notice here at the bottom I will write down those x and y coordinates. So you'll see here as I hover over 0.49, 0.86 is what I will remember. I will go to my screen entitled Jumping Mechanics, and for the wrist I will write in 0.89, 0.93. Let's double check that. Sorry, 0.49, 0.86, 0.49, 0.86. Right, then I go to the elbow, do the same thing in the middle, as much in the middle as possible. 0.73, 0.83, 0.73, 0.83. Then I do the same thing for the shoulder. 1.02, 0.79, 1.02, 0.79. Do the same thing for the hip. 0.61, 0.67. Same thing for the knee. 0.82, 0.37. Same thing for the ankle. 0.6, 0.1. Same thing for the toe. Most anterior portion. 0.75, 0.01. Okay, since we're assuming symmetry, I'll just copy and paste this down here. Select paste special in terms of these values, and that's my first frame. I will have to go frame by frame for the next 30 frames in order to digitize her entire jump. So you'll see that I click once forward and everything has moved slightly. So again, I would try and capture this as best as possible. You'll notice some slight blurring. The reason for that is because the movement is happening quite fast and the frame rate at which we were capturing was quite slow. It's only about 30 frames per second, which for this type of faster type movement is not ideal, but it will do for now because we're trying to learn the process, right? So I'd go through it, I'll do it one more time and then I'll show you guys the completed version. So this is 0.5, 0.71 for the wrist, 0.5, 0.71. Then the elbow is 0.74, 0.76. Shoulder is 1.0, 1.03, 0.75. Hip is 0.65, 0.66. Knee is 0.84, 0.35. Ankle is 0.61, 0.09. And finally toe is 0.76, 0.02. Again, I would just copy and paste this down. Make sure it's nice and symmetrical. Good, and so on and so forth. You know, frame 2, go through frame 3, 4, and all the way down to 30. You should have a nice summarized version at the end, which kind of shows you how this person was progressing through the jump, right? I'll show you the completed version. Once you're done, you would have this kind of a setup over here. So go to sheet 2.2 and you'll be able to scale through the complete jump using these buttons, left right buttons, which will take you forward and backwards in time, one frame at a time. So you'll see if I keep pressing this, it's basically an animated version of the entire jump as the person then lands, and that's my 30 frames completed. Okay, so that's what I want to show for this particular video. The next video goes through the actual analysis components. So yeah, that's it for now.